Last example of this lesson is going to be one more application of dot product where we can do something with vectors, and we're going to be looking at what's called orthogonal and parallel vectors. Now orthogonal, basically that just means that they are at a right angle. So there is an angle of 90 degrees between two orthogonal vectors. So an example would be just this is a vector, and here's one that looks like those two would be orthogonal vectors. The idea here, or the concept for orthogonal perpendicular, means that if we do u dot v, that it's equal to 0. So that's something that we're going to check with these, deciding if they are parallel or orthogonal. Parallel is, kind of like what you would think about it, but one thing to note is that parallel vectors can actually be right on top of each other. We've been taught in the past that parallel just means this only. They have to not touch whatsoever. But in terms of vectors, we can actually have two that are right over top of each other, because with vectors it really doesn't matter where it starts. So we could have one vector here, we could have one vector here, and those, even though they're right over top of each other, are considered parallel. But with these two examples, just deciding if they're parallel or orthogonal, so perpendicular there, just take the dot product to start with, because if the dot product does equal 0, then we can just stop there and say orthogonal. So part 1 here, we've got u dot v in this one. So that is 5 times negative 12, and then plus negative 6 times negative 10 equals negative 60 plus 60 equals 0. What a surprise. That means that we're talking about orthogonal. So for this first one, the two vectors are orthogonal, perpendicular to each other. Now, how would we know that that's true? Part of the reason that we can say that is based on what we had from the last example. The last example, where it was the angle between two vectors, if the dot product turns out to be 0, then that formula will yield a 90-degree angle. And so that's just a little bit of a background of where that comes from. For the other one here, we've got u dot v, which is going to be a little bit different. Let's try it first and just check to see if these are orthogonal to each other. So we have 5 times 10 plus negative 6 times negative 12, which is 50 plus 72. That is definitely not equal to 0. So we know that those are not orthogonal. Now the parallel thing is a little bit different. Parallel happens when two vectors are can be represented as multiples of one another. So for instance, you see that 5 negative 6 is exactly half of 10 12. So I could write this as 2 times 5 negative 6 equals 10 negative 12. If you can write a sentence like that where one is just a multiple of the other, then we are talking parallel. Now you might wonder, can I do it the other way? You can. We can multiply this by something. It's just going to have to be a fraction. So I could also represent this as 5 negative 6 equals 1/2 of 10 negative 12. If I can do either of those two, that means that they are going to be parallel.